Hi, good morning. Now we are going to see the basic introductions for the course Digital Electronics. First, we will start with binary digit, right? Uh, the basic terms bit and byte. What is logics, logic 0 and logic 1. So in binary digit, we used to represent with zeros and 1, right? So normally the digit 1 is represented by the higher voltage level, which is high or logic 1. A digit 0 is represented by the lower voltage level, which is called the low logic or the logic 0. In terms of the logic levels, we used to mention it as the positive logic level and negative logic levels in digital circuits. The higher value of voltage is considered as the logic 1 and the lower value of voltage as logic 0. Whereas in negative logic level, if the lower value of voltage is considered as logic 1, then the higher value of voltage is a logic 0. Then we have algebras, and in this we have certain laws and theorems. So these laws and theorems generally helps to reduce the number of terms or the number of variables that can be used in the digital systems. So that helps us to reduce the number of gates that can be used to design or create a circuit, right? So here the thing is we have to reduce the number of variables that in turn reduce the number of operations, number of components, number of gates required for a circuit design, right? So these theorems and laws helps us to do that. So generally used to perform the logical operators in digital computer. In digital computer, true represent high by 1, that is high voltage, and false represent by 0, that is low volt. So the basic logic operations are performed by the logic operators. Here we have listed the few fundamental basic operations, and disconjunction or disjunction, then not, that is complement. AND operator is, it performs the logic multiplications, that is xy is the input and x dot y, whereas OR operator is xy and the output is x plus y. Similar to this NOT operators, there is only one input x. If you are giving a 0, then output is 1, then 1 is input means then output is 0. Then we have this kind of laws and theorems, the commutative laws, associative law, identity law, inverse law, idempotent law, distributive law, then absorption law, elimination law, consensus theorem, involution theorem. So these laws and theorems, I already told that what's the usage of these laws and theorems behind the screen. The important thing is De Morgan's law, x plus y the whole bar equal to x bar dot y bar, x dot y the whole bar equal to x bar plus y bar. So let me discuss this laws one by one with the real example in the next video. Thank you.